Okay, so we're going to do Chapter 5, Practice E, problem number 2. So we're going to read the problem. It says a 755 Newton diver. So we're going to write our given. We're going to write our find. I have 755 newtons. Now, if I'm not sure what something is, I look at the unit. This is newtons. So newtons is a unit of force, so that's his weight, not his mass. So you have to be careful when you're reading the problem. He drops a board. He drops from a board 10 meters above the earth, above the water surface. So maybe I want to draw a picture to help me conceptualize it. Here's the diver, he's on a board, and now he ends up going down here, and that's 10 meters. Find the diver's speed 5 meters above the water surface. So at 5 meters, I want to find his speed, so I want to find VF at 5. And his speed just before he hits the water, which is at the bottom, which is at 0. So I'll call this V5, and I'm going to call this V bottom. So I'm going to call this the top. I'm going to call this the middle. I'll call this middle, and I'll call this the bottom. Can I call this anything I want? Of course I can. That's just a subscript. So I can call this initial, I can call this final, I can call this 5, I can call it middle. It doesn't matter. I'll change it to middle. All right. Conservation of energy says the total amount of energy remains the same. So the total energy at the top is going to be equal to the total energy. And right now I want to find 5, so it's the middle. So for conservation of energy, I know the total amount of energy remains the same. So the total here is the same as the total here, which is the same as the total here. Okay? So what I'm doing now is I'm doing from here to here. So the total energy at the top would be the potential at the top plus the kinetic at the top is equal to the potential at in the middle plus the kinetic at the middle. Now, I can look and think, is something 0? I can just expand that. Like if I want to, I can just expand and say, well, the potential energy at the top is going to be mgh at the top. This would be 1/2 mvt squared, and that's equal to mghm plus 1/2 mvm squared. Now, if you wanted to, before I got to this substituting in, I could have said at the top, remember it says he drops. So because he drops, we know he starts at rest. So I could have said right away that was 0. But I'll just go ahead and do it now. Maybe I wasn't sure. So the next step I want to do is say, is anything 0 at any point that I'm doing my calculation in? Now we're done with physics. I want to solve for this. Now I don't start plugging in values. That's how you make a mistake. Now I'm going to do basic algebra. So if you look at this, there's an m there, an m there, and an m there. I can cancel that out because I have an m in each term. Only if it's in all 3 terms, right? Now I want to solve for Vm. So what I want to do is I want to isolate this in the numerator all by itself. So because there's a plus, I'll subtract this. So now I'm going to have GHT minus GHM is equal to 1/2 Vm squared. But remember, I want V by itself. So to get rid of that 1/2, what I do is I multiply everything by 2. So 2 times 1/2 is 1. So now I'm going to have 2 GHT minus 2 GHM is equal to Vm squared. I still want V by itself, so I'm going to take the square root of both sides. So the square root of 2GHT minus 2GHM, remember that's a subscript, is equal to V. Now I could have pulled out the 2G, but I don't want to confuse anyone, so we'll just go with it the way it is. So I have 2 times 9.8 meters per second squared times 10 meters minus 2 times 9.8 times 5 meters. So when I do all that on my calculator, VM comes out to be 9.9. Now remember, with physics, you have a foolproof way to check your work every time. Now for velocity, it's supposed to be meters per second, but I need to check and make sure I didn't make an algebra mistake. So I'm going to look at my units. So underneath the radical, I have meters per second squared times a meter, which would be a meter squared over a second squared. So when I take the square root of the number, I also take the square root of the unit, so I end up with meters per second, which is my correct unit. And this is, now you don't have to write it all out. You can do this in your head. You can just look at it and say, oh, meter squared over second squared, square root of that, meter per second. But you have a foolproof way to check your work every time to make sure you don't have an algebra mistake. All right, let's do the next part. So the next part says find the total energy at the bottom. Or no, we want to find the velocity at the bottom. Now I could do conservation of energy between the middle and the bottom, but the easiest way to do it is if something is 0, do it between that. So because the kinetic energy at the top is 0, that's going to be easiest. So I'm going to do it between here and here. So what I'm going to say is, I'm going to say the total energy at the top is equal to the total energy at the bottom. So the potential energy at the top plus the kinetic energy at the top is equal to the potential energy at the bottom plus the kinetic energy at the bottom. But now, before I start substituting in, at the top, it's all potential. So this is 0. And at the bottom, which is 0, this is going, the potential energy is 0. So this makes it a little easier. So now I have mgh at the top is equal to 1/2 mvb squared. So I'll cancel my m's. Remember, I'm going to rearrange the equation to solve for the unknown in terms of the known. So 2gh at the top is equal to vb squared. So the square root of 2gh at the top is equal to vb. So now I'm going to substitute in my values. 2 times 9.8 meters per second squared times 10 meters. And when I do it on my calculator, I get VB is equal to 14 meters per second. That's it. It's crooked.